Let us solve conceptual problem in the topic both electrostatics and oscillation combined topic. One end of a spring of negligible unstretched length and a spring constant K is fixed at the origin 0, 0. A point particle of mass m carrying a positive charge q is attached at its other end. The entire system is kept on a smooth horizontal surface when a point dipole P pointing towards the charge q is fixed at the origin. The spring gets stretched to a length L and attains a new equilibrium position. If the point mass is now displaced slightly by delta L very less than L from its equilibrium position and released, it is found to oscillate at frequency 1 by delta square root of k by m. The value of delta is dash, they are asking. Now it is given that a spring of length, negligible length, unstretched length is negligible is given, whose spring constant k, one end of the spring is fixed at the origin. Now what we are doing is a point particle of mass m carrying a positive charge q, we are attaching to the another end of the spring. The entire system is kept on a smooth horizontal surface. Now we are placing a dipole at the origin. Due to this dipole, it produces electric field at this point. Electric field at this point is electric field. This is the axial line. So electric field at the axial line is formula, we know that K into 2P divided by R cube. R is known as here, L is given. Due to this electric field, here force acting on the charges F is equal to electric field into charge Q. Electric field at a point on the axial line into charge Q. So that electric force acts on these charges. E value is E A into Q we take. E value is K into 2P into Q divided by LQ. This electric force, electrostatic force is acting. As the electrostatic force is acting, so that this spring is stretched to length L. Now this as spring is stretched, elastic force is acting now. This elastic force is opposite direction to stretched direction. So elastic force acting is equal to, we know that force constant into elongation. Elongation is given that L. At equilibrium, now at this is the point, it is in equilibrium, let us take. At equilibrium position, elastic force is equal to electrostatic force. That means Kl is equal to, we are getting K into 2pq divided by Lq. This value we got. Now, by displacing the charge by small amount delta L amount we are displacing, then new length becomes L plus delta L. From equilibrium position, we are displacing delta L. Then force, electrostatic force changed to K into 2pq divided by distance is L plus delta L whole cube we have to take. In this case, now elastic force is acting. This elastic force is equal to K into L plus delta L. Now it is not in equilibrium since it is displaced certain distance, so that net force will be acting. That net force is equal to this electrostatic force minus this stretching force. Electrostatic force minus stretching force. Stretching force is known as elastic force. This electrostatic force we got K2pq divided by L plus delta L whole cube. Let us take L cube common, so that 1 plus delta L divided by L whole cube we got. Minus this F is known as K into L plus delta L. This F dash is K into L plus delta L. Here we know that the delta L 1 plus delta L by L whole cube is there. Now let us take to numerator. So K into 2pq divided by L cube into 1 plus delta L by L power minus 3. This delta L is very small, so that delta L by L is very small. 1 plus x power n in binomial theorem, we know that when x is small, 1 plus x power n we can write as a 1 plus nx. Here delta L by L is very small. By applying binomial theorem, K 2pq divided by L cube into 1 minus 3 into delta L by L we can write. Here minus K into L plus delta L is there. So we write here minus K into L plus delta L we are writing. Now see here, there is the net force. This net force we can write here as a this K2PQ by L cube multiply inside. So that we are getting K2PQ divided by L cube minus. We can take as this K2PQ by L cube as a KL. K2PQ by L cube as a KL. This one let us take as a KL. So this force is equal to a KL if you multiply inside KL into 1 KL minus 3 into KL into delta L by L, and this minus you take inside, so that minus KL minus K into delta L. Now we can cancel this KL and this KL, we can cancel this L and L we cancel here. Here minus 3K delta L, here minus K delta L is there. So that F is equal to, we are getting minus K3, the 3K delta L and the minus K delta L, so that 4K delta L. We are getting 4K delta L. Now this force is known as m omega square x. We can take this force value according to definition for simple harmonic motion. This force is equal to, let us take m omega square x. X is known as displacement from the mean position, that is delta L. So by combining these two equations, m omega square delta L is equal to magnitude, if we compare 4K delta L we are getting. So now we can cancel this delta L cancelled. Omega square is equal to, we are getting 4K by m we are getting. By taking square root, omega is equal to 2 root of K by m we are getting. Already we know that omega is 2 pi f. Omega value is 2 pi f, that is equal to 2 into root of K by m. Let us cancel this 2, and f is equal to 1 by pi square root of K by m. Now let us compare here. 1 by delta root of K by m is the oscillation frequency. In delta place, if we compare here, f is there. So that the value of delta is equal to, let us take as a pi.